Good morning and welcome to another session of CADS Clinics. Today we're going to take the layout that we worked on last time and we're going to add the insulators between the blocks for detection purposes. So at this point I will share my screen. There we go. And this is where we left off. This is our layout. Everything appears gray because it's dark territory. We haven't defined any detection yet. We have a branch line here that's going to remain dark territory. And this is our main line here, which is going to be CTC. So when you want to create a gap in blocks, you highlight one of the squares that's on the edge of that block, of the proposed block. So in this case, I'm going to define the block that is the gap between these two locations. And I always keep an extra segment of track attached to that central block because when we add the signal, we want it to be visible clearly on either side of the track. If we were to try to put it there, the track would run right through it. And you'll see that a little bit later on. But when we're ready to create those blocks, we highlight a block and we go up under details to track ends. And my window went to another display. And I can say if I want the block to be at the left edge or at the right edge. Well, at this point, I want it to be at the left edge. And it does adjoin the adjacent track, and that's the default, and that's normal. We'll discuss that in another session later. Once you become more advanced at doing this, you can skip ahead to define block and define signal on the fly. For now, we're going to come back to that. So all we're doing is saying that we're going to create a block boundary to the left side. We accept that, and you'll see it put a gap in our design. We need to do that on the other track. And again, I keep jumping up to my other display. And we want to do the same thing down here. And that'll be on the right side. Now, back in the days when we all got our first train sets and they were based on DC, and we had some kind of a selector system to assign different tracks to different power packs. This is all the insulation that you needed, or typically that we used, because there could be a train here or a train here, and it didn't affect this middle section. This middle section is only going to have one train on it at a time. So the switch didn't have enough space to actually have a train on it. So all we did was insulate just beyond the turnout of any single track, and we were done. The problem now that we're more advanced, getting in the DCC, doing operations, stuff like that, we can have a train on this block, but we still have a desire to throw the turnout. With CTC and the interlocking, the protection is there so that we cannot throw a switch underneath a train. So we need to be able to detect when a train is here, but still know that this is clear so that we can throw that turnout. So to do that, we add another block. And I'm going to make that a right boundary. And over here, we're going to make that a left boundary. All right. So now we've identified this as a control point named Charlie. This is a control point here named Delta. And this is the intermediate track. Now it's only two segments long in this particular diagram. We can make that as long as we want. Typically on a DTC panel, CTC panel, the intermediate tracks are not all shown. It's much shorter on their display because there's no control over it. There's nothing they can do with it. There's no turnouts, et cetera, et cetera. So now we need to go to a different style of switch. Um, Over here on the left, we have a crossover. So I need to make the ends for that. Now, when I finish up off the additional block ends, I like to have them aligned vertically. So I keep that extra track segment in there. And you see the top line just went red because it lost its track name based on us cutting that track there. The other thing we need to do is put an insulator between the two tracks on that crossover. So we can go to either the top one or the bottom one. And when we go into track ends there, what we actually see is we can create an edge on the top, the left, or the right. In this case, we want it on the top. So that'll add a gap in between. We're going to clean up the track names at the end. So by having those extra track segments at the crossover, my signals will all line up for this control point. All right, another example we have here. This is a full 4-track interlocking. Common on the Pennsy. A few other railroads had 3, sometimes 4 tracks. But these are not passing tracks in between. These crossovers are all together, so it's all one control point. So what I'm going to do here is create a whole bunch on the left edge, and over here on the right edge. And now I've got to go through and put block boundaries in between each of the tracks. All right, so that interlocking is now done. I'm going to take a break for here a moment, and when I come back, I will have all the other breaks defined. So stand by. Okay, we're back, and I've created all of the blocks for all of the crossovers and turnouts. And you'll notice I also did our dark section. And the reason I did that will become apparent in a future session. You don't have to do it, but if you're going to be using a magnet board style of control, which Rodney refers to as DTC, on your dispatcher board, you'll want to have individual blocks, even though they're not detected. So at this point, we need to fix the tracks that don't have names that are showing in red. All right, so we want to rename our track segments that lost their settings. And to do that, we have to highlight an endpoint on the red segments. We go under details once again, down to track ends. And that break is on the right side. We have to give that station a name. And I'm going to call it, this is First Town. We're just going to call it Block 1 on the A track. And we also have to set the signal discipline. We're going to make it CTC. We accept that, and it goes gray again. It's still gray because we don't have detection assigned to it. So I'm going to go up here, track ends. Here's my defined block. And this control point is called beta. And we're going to use DTC here because that's going to be dark territory. And you see that gets fixed as well. Down here, track ends. Define the block on the left. That's going to be our west lead into the yard, and that's dark territory. Track ends, define block, east lead, DTC. All right, I'm going to take a break and I'll finish off what's left. Okay, welcome back. So I've now gone through and I've made sure that all of the tracks have block names and their signal discipline defined. So our main line, west to east, left to right, is all defined as being CTC. The branch line up here is defined as DTC. That's going to be dark territory. And as I said, I have put in block limits or insulators along here. That's going to come into play a little bit later when we want to use this as a magnet board for the branch, just as an alternate approach. So let's go take a look in the actual CATS application and see how this looks. I don't expect it to be different than it was before because we haven't yet put the detection strings here. So as far as the display is concerned, everything should be gray. When we come back, we're going to start working on assigning the detection sections. Thank you. See you then.